In this video, I will explain you what is an N-type semiconductor. So we have learned semiconductor has two divisions. One is intrinsic semiconductor and another one is extrinsic semiconductor. Intrinsic semiconductor is simply this one, semiconductor made with only one type of element. Now extrinsic semiconductor means adding with an impurity. So here we have only silicon. When we are adding an aluminum atom or when we are adding a phosphorus atom, that is an extrinsic semiconductor. And extrinsic semiconductor has got two divisions. One is N-type and another one is P-type. Now we are going to learn about N-type semiconductor. See the definition. N-type semiconductor is made when it is doped with a pentavalent element. Say for example, phosphorus, a measured quantity of pentavalent element. Now see, in this semiconductor, how many free electrons are there? Zero number of free electrons are there. Now it is heated to 300 Kelvin. Now this crystal is at room temperature. Okay. Now in room temperature, many of the electrons will get thermal energy and these electrons will come out. So one electron came out, one hole, generating one hole here. One electron came out from here, generating one hole here. One electron came out from here, generating one hole here. Okay. Now it has got 3 holes and 3 electrons. So I am going to mark these holes and electron. Holes are here. Okay, and these are free electrons. They can contribute towards conduction, right? So this free electron will come here. 1, 2 and 3. Okay, number of electrons and number of holes are the same. So this is the case of intrinsic semiconductor. Now to make it N-type semiconductor, what I will do, I will remove a silicon atom from here. So when I am removing a silicon atom, I am also removing its 4 electron from making bond. So there are 4 electrons contributed by silicon. So these electrons are still there. Its electron are there. But it was giving 4 electron here before. The silicon atom was giving 4 electron here for sharing. So the moment I have taken the silicon out, I am also removing these 4 electrons. Now I am adding a pentavalent atom, for example phosphorus. Pentavalency means 5 number of electrons in the outermost orbit. So 1 electron will come and occupy this position. 1 will come and occupy this. 1 will do this. 1 will do this. Are we done? No, we have an excess electron. Now this electron is an excess electron. Is there any holes made in this process? No. So it's an excess electron and these electrons are called as acceptors. What is acceptor? Sorry, donors. Okay, my mistake. Donors. Donors means these are donating electron. Acceptors we will call holes as acceptors. Not all the holes. The holes created by adding trivalent impurities are called as acceptors. But anyway, leave that as of now. We are going to call these are donors. These dopants as donors. Phosphorus is a donor because it can contribute an excess electron. But aluminum is an acceptor. That aluminum need 1 electron to accept, which means it is donating an excess hole. But keep that aside now if it is confusing you. But anyway, it has contributed an excess electron here. Okay, so what is this? These are donors. It has donated an electron. So with electron perspective we will call it. If it is donating electron, that is donors. Okay. Now see how many holes and electrons are there. 1 hole, 2 hole, 3 hole and 4 hole. 1 electron, 2 electron, 3 electrons and 4 electrons are there. How many holes? 1, 2, 3. 3 holes. Now out of 4 holes, out of 4 electrons, we can split as 3 electron and 1 electron. Now these 3 electrons are generated along with 3 holes. These are electron hole pair generation, and these are done in intrinsic nature itself. These are done due to thermal acceptance of due to the thermal energy. When it is thermally excited when it is kept at higher temperature, electron hole pairs will be generated because electrons are accepting energy, and that will go out from its lattice, leaving behind a hole. So these are 3 electron hole pairs generated due to the thermal energy, and this excess electron is generated due to addition of donor, okay, or addition of dopant. So here addition of donor means simply it is N-type semiconductor. Dopant means dopant can be donor or acceptor, okay. So adding a donor having a nature of having a dopant having a nature of donor would be the creation of N-type semiconductor. So I have added a donor here. I have added I can explain this process in different way. Adding a pentavalent impurity, or adding a pentavalent dopant, or adding an impurity which is donor. So all these are representing the same process, okay. So anyway, I have added a donor here. These are donor, these are electron, excess electron given by donor. So these are pentavalent impurity, okay. Now 3 electron hole pairs generation due to thermal energy, and we will have 1 excess electron, and its energy would be slightly less than energy due to conduction band. These are energy of the conduction band, okay. Now this energy gap is approximately 0.01 electron volt, but anyway this dotted line represent energy of donor. Now energy of acceptor will come here, slightly above valence band. These are energy of acceptor, okay. That we will learn in P-type semiconductor. So this process is very important. When we are, instead of silicon, when I am adding phosphor, it gives out 5 electron, and out of that 3 electrons are shared by 4 electrons are shared with nearby 4 silicon atom, and getting a valency of 8 and getting a stability. This excess electron is fit for conduction, okay. Now when we are comparing the number of charge carriers, we come to know that the total number of positive charge carriers is less than total number of negative charge carriers, because adding 1 donor will give 1 excess electron. So say for example, if I have added 3 phosphorus atoms, so 3 each phosphorus atom will give 1 excess electron. So this will have 3 electron in excess. Now in addition to that, it will have electron hole pairs generated due to the thermal energy. So always when you are counting the total number of electrons and total number of holes, in N-type semiconductor, number of electrons would be more than number of holes. So these are called as N-type semiconductor. But if someone is asking what is the net charge of the crystal, the answer is 0, because from a neutral crystal we have taken a neutral atom, that is silicon atom, and we have added a neutral atom in back. What is the neutral atom? Phosphorus. So the net charge remains the same, but the change here is when we are comparing the charge carriers, number of electrons are more than number of holes, so it is N-type semiconductor, okay. This one is very, very important, and that would be N-type semiconductors are created with addition of pentavalent impurity, okay. Thank you.